perfect morning in Albuquerque, aside from the traffic. I know for...
Well, good morning and even good afternoon for some of the folks tuning into this international broadcast today. And the first thing I want to do, of course, is on behalf of the city of Albuquerque, welcome to everyone, all our visitors, all our guests, all our scientists, and of course everyone tuning in from all over the country. Most importantly, the National Oceanic and Atmospheric Administration. Thank you so much for the live stream. Good job. I know we also have some folks from NASA here and all sorts of amazing guest speakers that we're going to be hearing from. But I wanted to kick things off, I think, firstly by just painting a picture for those of you who are tuning in on the live stream. So we're in the high desert. There's a beautiful Sandia mountain on one side of us, and there's some volcanoes on the other side, and there's the Rio Grande River flowing right through the center of that landscape. And of course, today, as is the case always in October in Albuquerque, we have hundreds of hot air balloons filling the sky. And so in some ways, we've been training for this eclipse all the time, because every time everyone knows a balloon passes in front of the sun, we're all like, it's like shade all of a sudden, and if you're hot, it gives you a chance to be cool for a second because the sun was beating down on you, and it's the reverse, you want that balloon to go really fast if you're cold because you're freezing and you want that sun back. So we're very used to this every single morning in Balloon Fiesta. But of course, not quite like an actual eclipse. So today is a show like we have never seen before in Albuquerque, New Mexico, and timed wonderfully with amazing events happening right here at our Albuquerque Balloon Museum. It's the only museum of its kind in America. And also out in our balloon field. So we have roughly about 100,000 people every day out here, including today. And it's basically a sold out show for us here today. Parking is mostly gone. And that rarely happens. Since I've been mayor for 6 years, that's only happened once before. We know that this eclipse event actually added 100,000 extra seats coming into the city. So Mother Nature is doing her thing and really eclipsing every other Balloon Fiesta we've ever had. So for us, I want to, I think, just mention a couple of other things, because we are the home of some amazing scientists. So we know it's not necessarily particularly in this area of study, but we are the home, of course, of Sandia National Labs, and we have an amazing Air Force base here with all sorts of Space Force components as well. And so we have a long tradition of science and of believing in all things when it comes to what brings us together in terms of nature and of science in our community right here in Albuquerque, New Mexico. We're also the home of the VLA, just, of course, about 45 miles, 60 miles south. We have an amazing facility there that I'm sure many of you are aware of. So I think with that today, lastly, just in terms of history, we don't know if this is going to happen again. Some of you may know, but for us, we're all saying this is a once-in-a-lifetime shot. And so we're very glad to celebrate it together with this community. So with that, I'm going to hand it back to our organizers. And thank you so much to everyone who's here and everyone who's tuned in. And when you get a chance, if you're not here, definitely come visit us next year for Balloon Fiesta or any time of year in Albuquerque, New Mexico. Thank you.
Nan, Mayor Keller, thank you for spending some time with us this morning for the introduction. My name is Eric Green. I'm a meteorologist at KOAT Channel 7 here in town, and I'm going to be helping us along as we get through this event and enjoy the show. And we have so many VIPs and speakers that have also come here to spend some time with us, and we want to give each one of them a little time to talk about what they like about the eclipse and why we studied the sun. And so let's get right to it. First, it's going to be Dr. Michael Morgan. He is the NOAA Assistant Secretary of Commerce for Environmental Observation and Prediction. Dr. Morgan, he has more than 25 years of demonstrated scientific leadership experience. Before joining NOAA, he served as a professor and associate department chair in the University of Atmospheric and Oceanic Sciences at the University of Wisconsin-Madison. Spent some time in Madtown there as a Badger. I grew up in Minnesota, close by, so I know Wisconsin and Wisconsin-Madison pretty well, so I think that's pretty cool. So let's get Dr. Michael Morgan up here and enjoy the show. One thing, if you're new to Albuquerque, and I know a lot of you are watching online, but we are like the land of 2 and 3 outfits a day, so we're all bundled up, but in about 2 or 3 hours from now, it's going to be time for short sleeves. It's just kind of the days change like that here, but that's why we love New Mexico and Albuquerque so much. So Dr. Morgan, if you're ready, come on up. Welcome. Thanks for coming in.
Thank you very much for that introduction, Eric, and good morning. What a wonderful morning it is to see this balloon fiesta. The mass ascension this morning was really awesome, watching the balloons as they're taking off. I hope you're as excited as I am to see this annular eclipse. NOAA is honored and pleased to be hosting the viewing events here in Albuquerque along with our distinguished partners, and I really do want to thank our partners with National Science Foundation and certainly NASA, our federal partners in this endeavor. For scientists and spectators alike, every eclipse of the sun continues to captivate our attention. And it's our curiosity that compels us to find out more about how the sun operates and to learn how to predict its impacts on life here on Earth. NOAA looks at the sun 24 hours a day thanks to our solar ultraviolet imager that flies on our GOES 16 and 18 geostationary satellites. Also, NOAA's Discover satellite, perched in a Lagrange point 1 orbit a million miles from Earth, between our planet and the sun, acts as an upstream gravitationally moored buoy, measuring the solar wind as it comes toward the Earth and carries the powerful NASA EPIC camera along with it, which gives scientists an unobstructed view of the Earth. In April 2024, NOAA's newest geostationary satellite, GOES-U, will launch into orbit, carrying a new coronagraph built by the Naval Research Laboratory to observe the sun's outer atmosphere, or corona, where severe space weather events originate. This instrument will provide critical, accurate, and timely space weather measurements for NOAA's Space Weather Prediction Center, which is the official space weather government agency in the United States that provides alerts, watches, and warnings for space weather disturbances. But we're not stopping there. NOAA is actively developing future missions to observe space weather, starting with the Advanced Space Weather Follow-on Lagrange 1, or SWIFO-1 as we call it, satellite. SWIFO L1 is scheduled to launch in 2025, and it will be stationed in deep space at Lagrange point L1, the same orbit as Discover. Again, I thank you all for coming out and joining us. I hope you enjoy a safe and stunning eclipse. Thank you very much.
All right. Well, up next, we're just going to keep moving along here because we don't want to go, of course, over into the eclipse because we want to be sure to be able to view this in all its glory and all its awe here. Up next, we have National Science Foundation, the NSF. We see their stuff around here all over the place. It's Dr. Timothy Patton. He's the Deputy Assistant Director of Geosciences. Dr. Patton's been a leader within NSF for approximately 14 and a half years, and prior to that, he was a professor of chemistry at the University of California, Davis, UC Davis. He graduated from the University of California, Berkeley, with a PhD in chemistry. So, Dr. Patton, come on up. Thank you for coming in.
Thank you. Good morning. What a wonderful morning here in Albuquerque in the Balloon Museum, and what an exciting day. So we're thrilled to join you here for this annular eclipse observing event. And it's great to be here with our agency partners, NOAA and NASA. Together, we're 3 of the leading federal agencies for scientific research and discovery. NSF's mission is to invest in scientific research that advances knowledge. Our support for solar research goes back to the very beginnings of our agency in 1950. The National Solar Observatory was established in 1952, and today it operates several solar telescopes and research facilities around the globe, including the Sunspot Solar Observatory right here in New Mexico, and the Daniel K. Inouye Solar Telescope in Hawaii, which has produced the highest resolution observations of the sun's surface that have ever been taken. Eclipses are an important part of how we study the sun. A solar eclipse in 1919 helped confirm Einstein's general theory of relativity, and we can use them to better understand things like the sun's corolla, solar physics, space weather, the Earth's atmosphere, and so much more. But whether you're a scientist or not, A solar eclipse is an experience like no other. They are awe-inspiring events, and you may only get to witness a few during your lifetime. After seeing their first eclipse, some people become eclipse chasers, traveling to the ends of the earth just to experience those few special minutes again and again. We want you to have a memorable and safe experience today.
Just a little closer to the microphone.
Okay, thanks. Yeah, so over at our table, NSF has fact sheets on how to view the eclipse safely, and also has provided solar eclipse glasses. You should never look directly at the sun without eclipse glasses. You should never look through a camera, binoculars, or a telescope unless it's been equipped with special purpose solar filters. You'll need to continue to wear the eclipse glasses even during the ring of fire at the apex of the annular eclipse. For anyone who's curious to learn more about eclipses, solar phenomena, astronomy, or any other part of science, you can find more resources at our website, nsf.gov. Thank you, and get ready for an amazing experience today.
We'd like you to chair there for you. We've got a cloud demonstration coming soon. All right, thank you very much. Up next for us, exciting here. This is Margaret Peg, we call her, or she calls herself, I guess, Luce. Miss Luce, she's the Heliophysics Division Acting Director. She joined NASA's Goddard Space Flight Center in 1987 following 6 years of engineering experience in the private sector. She's been involved in the development of spaceflight systems to support NASA's science programs. She served in many leadership roles within NASA during her 36-year career. She's the president and CEO of the Center of Science and Industry. I'm sorry. I went too far there on the script. Anyway, let's bring Dr. Luce up here before I keep going and give her even more accolades than she has already deserved and earned. But come on up. Thank you for coming.
Thank you so much. And I'm not even a doctor, so there. So you don't have to be a doctor to work for NASA. So good morning, everyone. Before I start, I just want to thank the city of Albuquerque and the state of New Mexico for hosting us this week. It has been such a pleasure being here at the Balloon Museum, and you're experiencing your amazing, amazing balloon fiesta. For many of us, including myself, this is our first visit to Albuquerque and our first balloon fiesta, but I know it will not be the last. Thank you, thank you. Everything from the hospitality to the food to these spectacular views has all been wonderful. We can't thank you enough for your warm welcome and generosity throughout our time here. And while all eyes are on your skies, which is wonderful. So thank you. So the sun touches everything. Yes, I'm the director of heliophysics, which people may not be familiar with that term, but helio stands for the sun, and physics is the study of matter and energy and how they interact. And so the sun touches everything. It's one of the things that unifies all of us, and it has brought us all here together today. I have the privilege of working on and studying one of the most mesmerizing and fascinating things in our universe, our sun. Today, you will hear from NOAA, National Science Foundation, and NASA experts on why studying the sun is so important. What we learn not only helps us understand and mitigate impacts of space weather here on Earth, but it also helps us and enable us to advance our ability to explore further. So I want to welcome you to today's event and also invite you to join us as we study and explore the sun through an event that we are calling the Heliophysics Big Year. The Heliophysics Big Year is a global celebration of the sun where we are challenging everyone to experience as many sun-related activities as possible. It kicks off today with the Annular Eclipse and runs through December of 2024, when our Parker Solar Probe, which regularly flies through the atmosphere of the sun, will reach its closest approach to the sun within 4 million miles, which is very close. So once again, thank you so much for your wonderful hospitality. I look forward to experiencing the amazing eclipse. And again, I invite you to join us in the Heliophysics Big Year. Thank you.
Well, when it comes to science, things can have long technical names, and so we're kind of forced to live in a world of acronyms. So we've got NOAA, NASA, the NSF here on stage, and up next we have another acronym for you. Not to be outdone at all, but now we have COSI coming in to give us a little bit of a science display here, and I think we're going to work on building a cloud, actually, and we're going to keep our experts on stage for this as well. So this is going to be a lot of fun, but COSI, here they are.
Well, good morning, everybody. My name is Erica Oliveros Vincent, and I'm the Director of External Affairs at COSI. We are a science center located in Columbus, Ohio. We are here, we are here today with our solar STEM kits. They include 4 activities along with some solar eclipse glasses. Please come visit us next to the NOAA, NASA, NSF booths back there, and we'll give you a kit to take with you. Today we're going to be doing a dry ice cloud demonstration with our lovely NASA, NSF, and NOAA representatives. Dr. Morgan, Dr. Patton, and Ms. Luce, if you'd like to stand up and wave really quickly. Alrighty, you guys want to come on up to do the science experiment? Kevin, do you want to kick it on off?
How are we doing? Are we excited? Yes. Excellent. Well, today we're going to make a cloud. There's not many clouds in the sky, thankfully, today, because we have lots of really beautiful things to be looking at. So we're going to make one right here on stage today. Does anybody know the 3 things we need to make a cloud? Water? Cold? And we need dust or particles in there to bind it all together. So we have some of that flying in the air. We've got something really cold up here. We have dry ice. It's negative 109 degrees below 0 Fahrenheit. And we have our water. We have our friends up here. You guys all have glasses on, so you may not have to wear the safety glasses. But if you want to come up here, we need you guys to, we're going to be pouring in all of these different containers. Can I get 2 more people from the audience? Oh, right here? Yep. One more? Oh, yeah. There you go. Come on up here. You're going to be standing on the ends here. Let's get you 3 right here in the middle. I'll have you go right up here. You'll grab this one. Sir, you'll grab that big one on the end there. You can grab these 2. You're going to grab this cup. You're going to grab that cup on that side there. So you're going to be pouring into this one. You 2 of these are going to be pouring into the water. All right, are we ready? We need an official countdown. We're going to start at 5. You guys ready for this? Get those cameras out. Here we go. 5, 4, 3, 2, 1. Let's make a cloud. Excellent. Look at that. We're making a cloud right here on stage. Thank you guys all so very much for having us here. Make sure you check out our tent over there. We have tons of solar kits to hand out today, so come check it out.
Thank you.
Well, how much fun was that? Fun with dry ice, you know? Feel like I just had some lobster shipped in, you know, and next time I'm going to make a cloud at home with my kids here. So we'll move along here. Up next is a New Mexico local here. This is Mr. Jim Greenhouse. He's the Space Science Director at the New Mexico Museum of Natural History and Science. They preserve and interpret the distinctive natural and scientific heritage of our state through extraordinary collections. That's a great place to go visit and see. They do research, there's exhibits there, programs designed to ignite a passion for lifelong learning. We're going to talk now about eye safety, which is a big concern here, of course, with viewing the eclipse, and we've all got these eclipse safety glasses here, but let's bring up Jim. Jim, good morning. Thanks for coming on out. Oh, you brought cereal too, huh? Some Chex Mix for us?
Well, sort of.
Okay, sort of. All right.
Thank you. Yes. All right, good morning, everybody. I am very, very, very grateful that the only clouds that we have to worry about today are the ones that they just made on the stage here, and that we don't have any clouds up in the sky, so that we can enjoy this incredible eclipse that's coming up in just about 45 minutes from now is when it'll start. Have any of you lived here since 2012? Okay, one person in the back has. So you may remember that we had an annular eclipse come across Albuquerque in 2012. This was a famous picture that was taken during that eclipse. You can see the name of the photographer down in the lower right corner, and you can go to that website if you'd like to learn more about it. So that was just 11 years ago. Now, on average, it takes about 375 years for a similar eclipse to go across the same place on the surface of the Earth. So having one occur just 11 years later is really unusual, and just the first in an amazing series of coincidences that have led us to today. So, there we go. Sorry. So, not only are we getting an eclipse very close to one that we had just a few years ago, but when is it happening? During Balloon Fiesta, which is the biggest event that happens in New Mexico, I believe. And this was not, they didn't reschedule the Balloon Fiesta in order to coincide with the eclipse. This is just another coincidence that happened. And if that's not enough for you, there's more. Albuquerque is in exactly the right place to see this eclipse perfectly. So if you look at that map there, you'll see that there is a gray area, and Albuquerque is right in the middle of that gray area. So what that is indicating is the path of what is called annularity. So that means that anybody who lives in that path is going to see the sun turn into that same ring of light like you saw in that first picture that I showed you. And you see that we're right in the center, so we get to see the perfect ring of light if you look at the eclipse safely. Okay? So we're getting a similar eclipse. We're in exactly the right place and exactly the right time. How could it be better than that? Now, we want to make sure that we view the eclipse safely. And I think I have an animation that'll show you what we're going to expect here in just a minute. Let me see if I can get it to run. There we go. All right, so at about 9:13, you're going to start to see the moon hide the sun, because that's what causes a solar eclipse. This is greatly sped up. The whole eclipse is actually going to take about 3 hours. But at about 10:34, we're going to get what is called annularity. So that's when the sun is going to look like a ring of light in the sky, just like that. Okay? And you're going to see it just like that from here. The reason this is an annular eclipse is because the distance between the Earth and the moon changes all the time, because the moon has an elliptical orbit. And so the moon is actually just a little bit too far away from us right now to completely cover the surface of the sun. And so that's why you're going to see that ring of light around the edge of the moon. Now, if even 1% of the sun's surface is visible, that means that it's not safe for you to look at it without eye protection. So let's talk a little bit about how you can watch the eclipse safely. This is the danger. So this is a diagram of what your eye looks like, and you can see that your eye has a lens inside of it. So if you bring in the sun and you point your eye directly at the sun, you're basically focusing the sun's light onto a little burning point on the back of your eye. And this is actually a photograph of the inside of somebody's eye who looked at the sun for too long. This is called solar retinopathy. And if you damage the inside of your eye like that, it may never heal up. So you want to be very careful. And fortunately, there are a lot of ways in which you can watch the eclipse safely. So I went over the part about the eye damage already, and that there is no point during this eclipse that you can look at the sun. But and these are all kinds of things that I've had people ask me about over the past few days. It doesn't matter if you stack up 2 or 3 or 4 pairs of sunglasses; they are not going to protect your eyes sufficiently. Neither will smoked glass or potato chip bags or reflections in water. None of that. But There are ways that you can look at the sun indirectly. So there's no safe way to look at the sun directly, but there are several ways that you can look at it indirectly where you can enjoy this eclipse in just a little while. So it's hard to find a tree. I'm looking around over here and to see if I can find a tree. It's kind of hard to find a tree out here. But if there are any trees around, the gaps between the leaves and trees actually make little pinhole projectors, okay? If you get a hole that's small enough, it actually acts like a lens. And under these trees, under trees on any sunny day, you're going to see little circles. And those circles in just a little while are going to turn into little crescents, and then at just the right time, at 10:34, you'll see them turn into little rings, okay? And so that's because of those pinhole projectors that are being made by the gaps between the leaves. You can make an artificial pinhole projector by just poking a hole in pretty much anything that is opaque. We have, at one of the tables over there, we actually have some pinhole projectors that look like this. This is a NASA mission called PUNCH, Polarimeter to Unify the Corona and Heliosphere, is what that acronym stands for. And this is a NASA mission that's going to launch in just a few years to actually study the sun and the sun's atmosphere. But these little projectors have a circle, square, and triangle in them. And if you focus them in a certain way, you can see those shapes. But if you change the focus just a little bit, you'll see all those turn into little circles. Those are actually projected images of the sun. So those are available. Some of those are available at one of the tables. You can actually make your own pinhole projector out of a cereal box. So that's why I got the cereal box here. What you want to do is this is actually a different kind of device for looking at the sun that I'll talk to you about in a minute. But you can take another kind of cereal box and make a pinhole projector out of it. Basically, you just need to cut a white piece of paper, put it on the inside of the box, and then you cut 2 holes in the other side of it, and put a piece of aluminum foil over one part, poke a hole in it. That's your pinhole projector. And then you look through the other hole. You're basically looking at that white piece of paper that you put at the other end of the box. And when you point that aluminum towards the sun, you'll actually see a little projected image of the sun inside that box. And that's a totally safe way to look at the sun. All right, so then we have solar glasses. There are also quite a few of those over at several of the tables over there, so go grab a pair of those in the next few minutes. Make sure that they are intended for safe solar use. They should say something like eclipse glasses or safe for solar viewing on the back side of them there. Also, down at the bottom there it says down, up, down. What do you think that means? What that means is, can't tell you how many times I've seen people do this. They put the glasses on, they look up at the sun, and then they go, "Oh, pretty." And then they take the glasses off, and then they're staring at the sun, which defeats the whole purpose. So please remember to put your glasses on while you're looking down, then look up, then look back down again before you take the glasses off, and then you're then you're practicing safe solar viewing. And also at some of the tables over there, we have some little viewers like this, which are great if you have a cell phone, because you can use these to hold up in front of your cell phone camera, and then you can take a picture of the sun during the eclipse too. And I think we have a significant amount of those over at those tables, so there should be enough for everybody. All right. If for those of you who are watching, if you can't get to a pair of solar glasses or viewers, the reason I brought this up here is because this triangle or this rectangle that you see here is actually a piece of welder's glass. Okay, it's shade 14 welder's glass. That's totally safe for looking at the sun, but it has to be shade 14. Anything that's less dense than that will not protect your eye sufficiently. And the reason I taped it into the cereal box like this is because if you're just holding it up in front of you, it's kind of hard to not accidentally look at the sun while you're holding the glass up. But if you put it in something like this and then look through that, then that's a safe way to do it. All right, so here are some websites that you can go to. This top one is a list that we put together at by Museum at the Museum of Natural History and Science. We actually helped put together a consortium of different observing sites. There's over 20 of them across the state of New Mexico where you can go and enjoy the eclipse safely. These other websites will give you tips on viewing the eclipse. NASA, of course, AAS stands for the American Astronomical Society. GreatAmericanEclipse.com is they're actually based in Santa Fe here in New Mexico. They have a lot of great different maps that you can explore, that you can look at to explore eclipses. Time and date, you can put your exact location in and it will tell you precisely when the eclipse will begin and end in your location. There are also some apps that you can download. You can watch streaming video on several different websites. I think we're going to feature some of the streaming video on this broadcast, actually. So we just want you to be safe and have fun. And I'm going to actually be looking at the sun in several different ways over here, just to the left of the stage. And I may move my setup behind the tent just so that I can make sure that I'm looking at the eclipse the entire time, that it doesn't go back behind the building. So come over and have a look at the sun. And just remember that the eclipse officially begins at 9:15. Now, is there any way that anybody can guess when annularity starts? It's on my shirt. So at about 10:34 is when annularity starts here in Albuquerque, and the middle of the eclipse is around 10:38. And then the annularity only lasts about 4 minutes and 45 seconds, okay? So the entire eclipse lasts about 3 hours, but that window of opportunity where the eclipse looks like a ring of light in the sky, that only lasts 4 minutes and 45 seconds. So make sure you get your eclipse glasses and your projectors and you're ready right around 10:30, all right? Does anybody have any questions? All right. Well, if no one has any questions, then I'll send it back to Eric, and I hope you all have fun watching the eclipse today.
Thanks, Jim. That was great. Thank you, Jim. That was great. A lot of good info there. Love the visuals. We had a little taste of Balloon Fiesta almost come knocking right on our door here with a balloon coming down about 20 feet away. Don't know if you saw that, but that's Balloon Fiesta. Sometimes you're having coffee and all of a sudden a balloon comes down in the road right in front of your house. And it's like, oh, we got to go help those people. So it's just part of the fun here. We are going to move on now and get to our next speaker, Dr. El Said Talat. Dr. Talat is the director of NOAA's new Office of Space Weather and Observations at NESDIS. More acronyms here in the world of science. NESDIS. Maybe he'll tell us what that means. I don't want to put you on the spot because that is six things I have to memorize there. But within the office, Dr. Talat's leading a dedicated team providing oversight of the development, acquisition, integration, installation, and acceptance of major system elements for space weather satellites. Dr. Talat, he received his Master's of Science and Doctorate from the University of Michigan in Atmospheric and Space Science. He's a Michigan Wolverine. So we're going to talk about what is a solar eclipse and how does it pertain to us. So Dr. Talat, come on up. Thank you.
No go blue from the audience? Come on. So I'll say it. I'm from the Office of Space Weather Observations at NOAA's Satellite Information Service. NESDIS stands for the National Environmental Satellite Data and Information Service. And so, yep, you got it? I got them right. Okay, nobody fact checked me on that. But that's, so I'm here from NOAA to talk to you about solar eclipse and how that is key. That's key to unlocking the space weather at the sun. Oh, yeah, can I have the... Oh, who's got the clicker? All right, well, we'll go. Next slide. Yeah. So our first scientific discoveries, of course, as a species, came with our eyes. We saw the beautiful aurora. We see, and we've had thousands of years of viewing the aurora, hundreds of years of viewing sunspots from the visible light from the sun. And of course, celestial phenomena such as comets and etc. And from the sunspots and the sun in the visible light looks relatively constant and not very variable. But when in the rare times we have a total solar eclipse, next slide please, we are able to see the outer atmosphere of the sun, what's called the corona. And during this time, we see that the sun's atmosphere extends far beyond the disk of the sun. And we also people were able to see that this was variable. It was not a constant, not a constant atmosphere that was going on. And it gave us a glimpse of the power of the sun and how much we don't understand about it and how much we need to research so that we can help protect, to understand what happens there and understand how we can protect against events that can affect us here on Earth, those type of things that we call space weather. All right. And so now we know from our observations from the ground and from space, that we live in an extended atmosphere of the sun. The sun extends out, and that's what defines the edge of the solar system, the atmosphere of the sun. And so it's we know from observations that this is no, the movie's not working. Know from observations that it's highly variable. When we look at the sun in different wavelengths, it's constantly changing in ultraviolet, in X-ray radiance, and even in infrared and in visible light, of course. And then the sun also extends out by streaming particles, ionized plasma, ionized gas, which is called plasma, out into the solar system. And that's the solar wind. And sometimes when the sun is active, it goes through an 11-year cycle of activity. We have a lot of storms, flares, explosions of electromagnetic radiation off the sun, particles, particle events that radiate from the sun, and also sometimes large magnetic clouds, gases that explode off the sun and then sometimes can travel towards Earth and interact with the near-Earth environment. We are protected in large part by the magnetic field of Earth from these explosions. This is a simulation here of those explosions, an explosion coming to the Earth, and the particles, the energetic protons and electrons are deflected by the magnetic field, and lots are absorbed by our atmosphere. And we often see this type of radiation from the sun ultimately cause the beautiful aurora that we see there. And then this is a beautiful and visible manifestation of space weather. But space weather can also be quite dangerous. With these particles and electromagnetic radiation can affect our civil aviation, where they have to divert flights from high latitudes because it affects the communications. It can affect the changes in our upper atmosphere, can affect our navigation signals and high frequency communications that are needed for emergency responders, and also some of the largest storms can actually affect our technological infrastructure quite severely. Both the satellites in orbit, because they may experience higher atmospheric drag and changing their orbit, and then increasing the chances of collisions, and in a very large storm like happened in 1989, for instance, it can knock out parts of our power industry and electronic infrastructure. In Quebec, we lost power for millions of people for several hours. So it's when these large explosions, which are billions of tons of gas from the sun that's traveling at millions of miles per hour, they can interact with our near Earth magnetic field and induce these large geomagnetic storms that can induce currents on the ground that can damage our technological infrastructure. So we know. Let me try to get this to work. We know that that the key, now that we've been observing the sun for a few decades now from space, and the science and research we've done, we know that the key to understanding space weather here on Earth is the looking at the outer atmosphere of the sun, the corona. And so this is an image, this is a movie, I should say, from one of the ESA NASA research satellite that has an artificial instrument called a coronagraph that mimics what happens in a total eclipse. It blocks out the disk of the sun so we can measure the outer atmosphere of the sun there, the corona. And you can see it's highly variable with explosions coming off. These are these large explosions of magnetized gas called coronal mass ejections that explode off the sun. And those are what we really have to watch out for in order to safeguard our society here. The coronagraph is an instrument that's absolutely key to our space weather forecast, warnings, and predictions for us here on Earth, and for anybody, of course, that's going to be traveling to the moon or to Mars. So what are we doing about it at NOAA? NOAA provides environmental information from the depths of the ocean, in the atmosphere, the upper atmosphere, near Earth space, and out and at the sun. And so we provide the operational space weather alerts, the nation's official alerts, warnings, and forecasts, and we maintain ground-based and space-based assets to provide the data for those forecasts and warnings. And in specific, what we're doing right now, coming up, as you heard from Dr. Morgan, is we are building the first two. We have built, I should say, the first two operational coronagraphs that are going to fly. The first one is going to fly on the next NOAA geostationary satellite, the GOES-U satellite that's going to launch in 2024. And the second one is planned for launch in 2025 on the Space Weather Follow-On L1 mission. And both of those are going to provide these 24/7 observations of the corona, so that we can help that they'll feed into our forecasts and warnings. So this is a pictorial representation of the observing infrastructure we need to characterize space weather fully. Lagrange point 1 is upstream of Earth, as you heard, 1 million miles upstream. That not only gives us that unobstructed view of the sun so we can image the corona, but also gives us the upstream measurements of the solar wind as it's coming towards Earth. The other orbit that we have where GOES-U is going is in geostationary, and that gives us not only a view of the sun, but also the magnetospheric particles and the magnetic field near Earth. And then we're working with the European Space Agency on partnering them with on their mission to what's called Lagrange point 5, which is 60 degrees behind the Earth along its orbit. And that gives us, and we're going to have a third coronagraph at that vantage point. And from having the combination of the coronagraph in the Sun-Earth line and along at Lagrange point 5, you can see gives us a stereo view of these explosions off the sun, so we can better characterize these large explosions as they propagate towards Earth, and help us predict and give information to decision makers in the power industry, in aviation, in the satellite industry, that can help mitigate and prevent the impacts of space weather. And with that, I'll take some questions. But first, even though we're going to see, of course, the annular eclipse now, which is quite a beautiful display in itself, and so it's quite exciting. And we'll drop the mic there. So please, any questions? Yes.
I have this mirrorless camera. Will that be hurt by taking a picture of the eclipse?
We have actually some eclipse viewers that are designed so you can put it against your camera or your cell phone No, not those. Doug, you have them around your neck. That one. So that you can use that to image the eclipse for. I'm not sure it'll fit your whole lens, but yes, at the NOAA booth, which is right behind you over there.
You answered my question.
Right.
Will it hurt it though?
I don't believe that the optics are hurt themselves, but you shouldn't look at it without some protective through the viewer, without the protective eclipse viewer. Any other questions? All right, I'll get back to. Okay.
Because we may have an extra moment here, I had a couple of extra questions. I thought your presentation was fascinating. I guess I've read just a little about the Earth's magnetic poles reversing. Will that change our protection from solar blasts?
That's a very, very good question, and one that's a lot of fun to think about. We know that the Earth's poles switch north to south, south to north magnetically every roughly, I think, 300 million years or something. It's a very irregular pattern, and we're actually due statistically, but it could happen now, could happen in 30 or 40 million years. We don't know. And when that happens, there is a period of what we think of where the aurora, for instance, we see the aurora at high latitudes, at the north and south, because that's where the magnetic fields connect. The Earth is like a big magnet, right? And as they switch, there's a little confusion in where the poles are. It's not set. It doesn't set quite very quickly. We don't know how long it actually takes for it to switch. So we can imagine that you'll have lots of places where you'll see aurora at mid latitudes, low latitudes, etc. We don't think that that's going to change the protection we have globally against the particles from the sun. But what it will do is change where those particles are coming in locally. Instead of in the ring around high latitudes at the poles, it may be in different locations around, and so that's very exciting. Right now, the southern magnetic pole is actually in the geographic north, so it gives you an idea that it switches back and forth.
What will that switching do to the growing condition on the Earth?
Okay, so the question was, what will the switching do? What will that do to the growing conditions on the Earth? Or sure, will that affect food and crops?
We don't believe it will, because you'll still have the protection of the atmosphere and then the magnetic field globally, in a sense. But it is fun to think about what happens to the migrating animals that we know use the magnetic field as navigation, and whales, etc. So it's an interesting idea, but this has happened several times in history, and life goes on. Yes.
I have one more question. I don't want to hog all the time, but with these coronal mass ejections, is the sun getting smaller a little bit all the time then, as it shoots mass out?
Technically, yes, but it is so huge that the amount of matter that's being spewed is negligible at any particular time. But ultimately, yes, it is losing energy, and that's why in billions of years it's losing steam and it's going to become a red giant and ultimately absorb the solar system. But yes, technically it is losing mass, and
it's got a lot to lose, though.
It's got a lot to lose, and technically we lose a little bit of atmosphere when the solar wind strips it away, and that's what we think, by the way, happened to Mars when it lost its magnetic field. So we know billions of years ago, Mars had a magnetic. We believe Mars had a magnetic field, and it also had running. We see evidence of running water, but we know about 3 billion years ago, the magnetic field stopped, and so I'm sorry. Evidence of running water means it has a thick enough atmosphere to allow running water on the ground, but 3 billion years ago, the magnetic field stopped, and we believe that the solar wind stripped away the atmosphere of Mars over time, and that's why it's a barren desert now, as far as we can see.
Well, Dr. Salat, thank you so much for your time. We have Dr. Doug Biesecker coming up next. We are right on schedule here. We're actually starting to get ready to track the eclipse into North America, into the Pacific Northwest right now. So you're going to start to take us through the timeline of things and what's playing out right now. So Dr. Doug Biesecker, everybody.
Hi, welcome everybody, and I want to say thank you to the Balloon Museum for hosting us. What a wonderful venue and a great event, the Fiesta. I'm Dr. Doug Biesecker, representing NOAA. I had a 20-year career with NOAA, forecasting space weather at the Space Weather Prediction Center in Boulder, Colorado. I am now consulting NASA and NOAA on matters regarding space weather. So what we should be looking at on the screen, but we're not quite seeing it, is the eclipse is about to hit the shores of the United States. It's going to hit the shores of the U.S. in Oregon. I've got my phone out so I can see the time because it's going to
Annular solar eclipse occurs when a new moon passes directly in front of the sun but appears too small to cover it completely. But why is that? It's because the moon's orbit around Earth isn't a perfect circle, but rather an ellipse, or slightly oval shaped. This causes the moon to move closer to us and then farther away during its month-long orbit. When the moon is at its closest point, called perigee, it appears slightly larger in our sky. When it's farthest from us, at apogee, it appears a little smaller. But we don't see an annular eclipse every month. That's because the moon's orbit is also slightly tilted in relation to Earth's orbit around the sun. This means during most months, the moon is either too high or too low to block the sun. So only when a new moon is at apogee and passes directly between Earth and the sun, do spectators on Earth get the rare opportunity to see the ring of fire in the sky. Unlike a total solar eclipse, when the moon completely covers the sun, during an annular eclipse, the sun never fully disappears. So if you're lucky enough to be in the path of an annular solar eclipse, make sure to wear your solar eclipse glasses or use other safe solar filters to witness the spectacular ring of fire in the sky.
The All-American Solar Eclipse of August 21st, 2017 is set to be the year's biggest celestial event. The eclipse is a must-see, but you need to know what you're doing to avoid injuring your eyes. Here are some tips for enjoying safe sun. Rick Feinberg of the American Astronomical Society has seen lots of solar eclipses. He has some advice and warnings about viewing the August 21st, 2017 eclipse. He says everything depends on whether you're in the roughly 70-mile wide path of totality, stretching from Oregon to South Carolina. Only in that narrow zone will you experience a total eclipse, in which it'll get dark, and, weather permitting, you'll see the corona, the sun's ethereal atmosphere.
During totality, when the moon is completely blocking the sun's bright face, you don't use any filters. You look right at it. You can look right at it with binoculars, you can look right at it with a telescope. But at all other times, during the partial phases, before and after totality, or if you're not in the path of totality, throughout the partial eclipse, you must use safe solar filters.
What are safe solar filters, you ask?
The most common kind available now are these eclipse shades or eclipse glasses. If you go online and search for solar eclipse shades or solar eclipse glasses, you'll find many suppliers, many retailers who sell them. They're cheap, they're like $1 or $2 a piece. And they're made from a special material that blocks all but about 1/millionth of the sun's light. And that's across the whole electromagnetic spectrum, so it makes looking at the sun directly perfectly safe. So the proper way to use these is to not look at the sun, but to put them on and then look up at the sun. Dark sunglasses won't work. Any other filter that you can improvise won't work.
Feinberg also says one of the best ways to watch the eclipse, especially the total phase if you're in the path of totality, is with binoculars. There's just one thing to remember.
You cannot use them at any other time unless you have special filters that go over the front of the binoculars. Okay? These are only used this way, without any filters, during the total phase of the eclipse.
If you want to capture a souvenir photo, you don't need anything more elaborate than a cell phone camera. But as Rick explains, the same solar filter rules apply.
Except during totality, you have to use a safe solar filter, and it has to go in front of the camera. So what I do is I take half of one of those eclipse shades that I showed you earlier, and I put it over the camera, and I tape it on so that it doesn't blow off or fall off. And then I can just point my cell phone up at the sun, zoom in, and take a picture.
You can also resort to a true hands-on technique.
You put the sun at your back, and you get out of the way, and you cross your fingers, make a little waffle pattern with your fingers, and it creates several little holes between your fingers, and those project images of the sun right on the ground.
If you're within the path of the moon's dark inner shadow on August 21st, you'll experience a total eclipse lasting at most 2 minutes 40 seconds. During this brief phase, it's okay to look directly at the sun without filters. But at all other times, and at all times if you're outside the path of totality, follow the safety instructions Feinberg describes. Except during totality, never look at the sun through a camera, binoculars, or a telescope unless it is covered over the front by a safe solar filter. Never use eclipse shades while looking through a camera, binoculars, or a telescope. The concentrated sunlight will melt the eclipse shade you're wearing and injure your eyes. On August 21st, wherever you are in North America, enjoy the eclipse safely.
Heather Futrell with the NASA headquarters program with the Helios division up here. Just a little study and starting to play out right before our very eyes. So super fun. And boy, if you know anybody who doesn't have viewers or glasses, we've got some extra ones right up here in the corner. Just want to make sure that everybody's eyes are protected as we start to get into this. And so nice that you guys have found your spot. And I think we're just trying to round up Heather. But it's funny. We had one other expert coming too who is caught in traffic. I mean, apparently it is just like absolute gridlock out there on the roads trying to get in here. And we heard a rumor that all parking lots and spots are full. So everybody that right now is out on the roads waiting to get in, I don't know if they're actually going to be able to move anywhere. They may just have to get out of their cars, and hopefully they have their Eclipse viewers in their car, and they can just turn around and watch it from there, because I don't know if we'll be able to move on. So, you know, we're not in any rush. I see Heather back there. She's making her way up to the stage slowly. Heather Futrell, NASA Headquarters Heliophysics Division Program Executive. And you want to talk about experts on space and the sun? We've got them here, so we're very fortunate to have these experts. And it's a chance, if you have any questions for them, we can just, you know, kind of freewheel it a little bit. So they're all up here right now. So let's talk about this first, because I know this is kind of an easy maybe answer for you, but the sun, it's kind of a long ways away. How far is the sun from the Earth? Do we know that number? Okay. Do you guys, you know, and I'll just give you the microphone, and we can just go with it here. So.
Yeah, I have a few things, just some comments I wanted to make.
For sure.
So
Sorry.
Let me make sure the clicker's working here. Yes, it is. So yeah, good morning, everyone. How exciting is this? Perfect, right? And you know, we're watching the sun here, and everyone's getting this great opportunity to see this eclipse. If you ever visit us in Boulder, Colorado at the Space Weather Prediction Center, you'll realize we're watching the sun 24/7. Eclipse is fascinating and whatnot, but the sun does some other things that, yeah, it's fascinating, but it's also a little bit troublesome. So we put together a center many, many years ago, decades ago, to monitor the sun continuously because of what it can do to technology here on Earth. So you're seeing a picture there. If you ever get a chance and visiting Boulder, come see it. You'll see a picture of the Operations Center. So it's kind of like a regular weather station, except we're just not interested in hurricanes. We're not interested in tornadoes or snowstorms. We're interested in the sun. We're interested in the eruptions on the sun, the solar flares. When the eruption gets to Earth, the material that gets blasted out to the sun when it reaches us here on Earth, and what it does to our technology, what it does to that magnetic field. That's what we're interested in. Especially today, you know, we have created a vulnerability unlike any other, because we appreciate the fact that a big hurricane can cause a lot of problems on the Miami coast if it's bearing down, on the Florida coast if it's bearing down on Miami, or a major earthquake in San Francisco. But these things that you've heard a little bit about this morning, space weather, these eruptions in the sun affect the entire Earth, the entire country. So it's one big distinction. It's not unlike what we experienced in the last several years, the pandemic, which has global implications. When we get these big eruptions from the sun, we call them coronal mass ejections. You'll see one on the screen here, this big bubble of 1 billion tons of plasma gas that comes blasting out towards the Earth. The sun is shot out not just 1 billion tons of gas, but a magnetic field. Earth has a magnetic field. Two magnets are going to come together, and when they do, problems start. Problems start with the technologies that we rely on for everything we do today. And just to give you a kind of a snapshot of some of the technologies, just for a little bit of a deeper dive, and I will say this, up in the upper left-hand side is the main reason we exist. Potential impacts on the electric power grid. When these coronal mass ejections hit the Earth's magnetic field, it actually develops electric currents that flow through the ground, right up into the power grid. So one of our responsibilities in Boulder in Colorado is when we see the big CME coming, we recognize it's, we measure it's typically running about 2-3 million miles an hour. So it's going to take a day or two to get here. But when it does get here, it causes those currents. So we got to give the grid operators across the United States and indeed Canada a warning that that's going to happen, so that they can take action to protect the grid and keep the lights on. One of the key functions of the Space Weather Prediction Center. I also, when you look at the tractor, why Why would a farmer care about space weather? GPS. GPS pervades society today. There are so many uses for GPS. High precision GPS. So the farmers are using it now. We call it precision agriculture. They're out there with the tractors, and they can even do it at 3 o'clock in the morning, because if you're relying on GPS, you don't even need light. And they're spraying, they're planting seeds, they're irrigating, they're fertilizing with centimeter accuracy because of GPS. But during these big space weather storms, guess what? They lose that accuracy. Sometimes they even lose contact with the GPS system. So a farmer now, who would typically check on the weather before they go out and do what they need to do, now they check on space weather as well. One other thing I'll just mention, big exciting thing, and our NASA colleagues here are involved in this, of course, we're going back to the moon. Next year, the Artemis mission, the Artemis 2, we're back to the moon. That Earth, we're going to be outside Earth's magnetic field, which is more vulnerable to space weather. So NOAA and NASA working very closely together to get the information down to Mission Control and Johnson Space Center. Big radiation storm, we say, Houston, we have a problem, right? When those big radiation storms occur, the astronauts have to be protected from that harmful radiation. Satellites, aviation, all the different technologies across the board get impacted one way or another by space weather. So that was just a quick overview of an introduction to what we do in Boulder, providing those alerts, providing those warnings to keep this nation safe during these big space weather storms. Are we taking questions now, or are we run through the panel? Go ahead.
What's the frequency of the flares, solar flares?
Yeah, so we go through everyone's familiar with the hurricane season, right? No, we don't get hurricanes in January, February, March. The sun goes through a cycle as well, where the sun does something unlike Earth. It does this 11-year reversal of the polarity. So during that reversing process, these sunspots emerge, and they're the localized magnetic stressed areas in the sun. We're approaching solar maximum right now, so we're seeing quite frequently these eruptions. We will see maybe 2, 3, 4 eruptions on the sun. But one thing to keep in mind, the sun is a 360-degree ball of fire up there. There's just a few, maybe a 40, 50-degree window on the sun pointing towards the Earth. If the eruption occurs there, we sometimes call it the kill zone, then that eruption is coming right towards us. So we can see eruption on the right side of the sun, the left-hand side of the sun, and that material is going that way or that way. We're not as concerned, obviously. But right when it's in the middle, it's coming right towards us. So we'll see big events. And of course, what's the beautiful visible manifestation of geomagnetic storms? The northern lights, the aurora borealis, and the southern lights, the aurora australis. So just like the eclipse, it's on everyone's bucket list to see the northern lights. So we did see them down all the way nearly to New Mexico in March and April of this year. So it does happen, but right back to your question, we're seeing these eruptions occur almost daily, but the ones of significance maybe every other month or so during this phase of the cycle, which will go on for about another 3 or 4 years. So I won't hog the time. I'm going to turn it over to my NASA colleague now, Jim Spann.
All right, Bill. Thank you very much. Bill is a great spokesperson for really helping us understand the importance of space weather and the impact to our society. And as he said, this is a global issue. It affects everyone across the entire planet, including those few people who are orbiting the planet in the ISS or eventually when we're going to the moon. So at NASA, our role in this whole enterprise is really trying to get to the basics and understanding what's going on. How can we understand the dynamic nature of our sun and its impact and its connection to our planet, which has its own magnetic field, as Bill just very eloquently explained. And so understanding the sun and why it might have these different explosions are the things that NASA is really focused on. Oftentimes when you look at the sun, I mean, that looks so quiet, so, how could that be a problem? But you may have seen other images of the sun in different wavelengths, and it's a hot mess. It is, things are spewing out all over the place. Their magnetic fields, these hot plasma get entrained in those magnetic fields. If it energizes enough, then it explodes and has those solar flares or coronal mass ejections, as Bill explained, and then understanding how that is transported from the sun all the way to the earth. And we know like it takes 8 minutes for light to get here, and these very energetic particles, it may take several hours to get there. These coronal mass ejections, depending on how fast they're going, they may take 18 hours. And how can we better understand the sun so that we can do a better job of modeling those behaviors, and then those behaviors and those models then can feed into the predictive capability that our friends at Boulder provide to the nation. And we work collaborative across internationally. Bill mentioned the ESA mission. We have several missions. Earlier, Dr. Talat mentioned the ESA NASA SOHO mission that has been providing the coronographic images so that we can understand when these large coronal mass ejections are coming toward us. And so this truly is an international endeavor. And the Japanese we are working very closely with them on a new mission to look at the sun in the EUV. And so looking at the sun in all these different wavelengths helps us understand different aspects of what's going on at the sun. And that's what NASA is, really a mission-driven agency. And so we have many missions out there, and some most amazing, fantastic missions. Some are very international in nature. Well, actually, most are international in nature because we collaborate, certainly with the data, everybody. But some also have international participation with instruments. And it was mentioned earlier, the ESA mission to the Lagrange point 5, which is going to look at the sun shortly before it turns towards us, to that critical zone where we really pay attention, because if something happens there, we know it's going to come toward us here at our planet. And so, however, there's another very special mission that's been setting all sorts of records, and I'm going to let Heather Futrell talk about the Parker Solar Probe mission, the mission that actually goes inside the atmosphere of the sun, amazingly enough, and it survived to provide us data on it. So Heather, tell us all about Parker.
Thanks, Jim. All right. So yeah, the Parker Solar Probe mission launched in August of 2018, and it's been going strong for several years. There's really a couple of cool things about this project. So one, it's the closest mission we've ever had to, it's literally touching the sun. So it's flying through the upper atmosphere, otherwise known as the corona of the sun. And so when it first launched, and it's done it multiple times, it actually slingshots around the Venus planet. And as it does that each time, it gets closer and closer to the sun. And so the data that we're getting off of the spacecraft, it's insane. All the scientists are always excited when we dial into a science meeting. It's some really interesting data, because it's stuff that we've just never had before. You model the effects from the corona, but you've never actually flown through it and actually had real data. So it's an amazing mission. And so because you're in the sun, it's pretty hot. So they have this, there are 2 feats that actually help to cool the Parker spacecraft. So there's this carbon composite that's about 4 inches thick that's facing the sun, and that protects everything behind it at room temperature. And the other thing too, they use water to cool our solar array panels. And so that's what actually keeps the spacecraft flying. So Parker, it's actually going to have its closest approach to the sun next year in December of 2024. And so that's going to be the closest we get to the sun, and then we're going to keep going at that orbit around the sun, taking more data. And one thing too, so next year, as Bill mentioned, it's going to be our Solar Max. So it should be really cool to see what additional data we pick up during Solar Max. So, and another mission that you guys already talked about was SOHO. So what SOHO's doing too is it's got a coronagraph, so it actually blocks out most of the sun, so you can see the corona around the sun to do science. So just to kind of pull us over to the total eclipse that'll happen next year in April. So that's going to be another fun thing for us to go witness, because when you can see that, if you're in the path of totality where the moon's shadow is fully on Earth, for those probably 2 to 3 minutes, if you are in the path of totality, you are able to take off your safety glasses when you view the sun, and you'll actually see the corona with your naked eye. And because it's total max, it should be pretty cool to see some solar ejections coming out during that time. So that concludes what I had to share with you all, and I think we're going to be taking questions. So, yes.
Do you think it'll ever be possible for a human mission to get that close to the sun? Repeat the question.
So the question is, do we think it'll be possible for a human mission to ever get that close to the sun?
Not in our lifetime.
Yeah. It's a pretty hot environment. Yeah. Do you have other questions? Oh, back here. Does NASA still have a flying lab with a telescope, like the International Space Station?
No.
The Hubble.
Webb.
What? The Hubble and Webb. Those are both, yeah, Webb's still up, Hubble's still up. They're both still going. We're getting amazing pictures back from both of those telescopes. Oh, Chandra, yeah. We have, yeah. Astrophysics Division has a lot of great telescopes. Yeah, go ahead.
You keep the vehicle from burning up to get that close to the sun.
So how do you keep the vehicle from burning up when it gets that close to the sun? So, like I was mentioning, you've got that carbon-carbon composite on Parker on the front side, so that's right now what's keeping it from burning up. There's also some small thrusters that help to make sure that the spacecraft is pointed with that heat shield at the sun as it does its orbit, so that way you keep the sun hitting the heat shield and not affecting the instrument payload that's in the back. For about 4.5. Yeah, it's insane. Yeah. Next question? Yeah. When will humans make landing on Mars? So measuring the heat from the sun and how it would affect humans being on Mars. Okay, that's the question.
Let me just touch on that question because it's a good one. When we're doing these space weather predictions, and we see the eruptions in the sun. There's different types of emissions, right? So the electromagnetic radiation affects communications, but we also get these energetic particles, protons, and a big dose of them sometimes. So we're measuring them on our spacecraft, and one of the things we do is we advise United Airlines, Delta, American, all those folks, especially those that are flying polar. Now the Ukraine situation aside, we were flying polar prior to that. So if you were going from Chicago to Beijing, or if you're going from Newark to Hong Kong, typically with aircraft, they fly right over the poles. They love it, right? The airlines love it because it costs less. You can do it direct. It's green. There's not much turbulence up there. There are a few other issues, freezing fuel being one of them. But one of the biggest concerns is that radiation and how it'll hit the magnetic field lines of Earth. And where does the field lines come into the Earth? In the North Pole and the South Pole. So they concentrate there. So we'll get the airlines warned that this is happening, and they'll actually reroute the flights. But back to your question, I'm going to turn it over to my colleague at NASA to talk a little bit about it, because once you get outside Earth's protected magnetic fields, you're more exposed to that radiation. So you said, what about Mars, and what's that going to look like? Great question. What is the radiation environment going to look like? What is NASA doing? We're going to be back to the moon next year, circling the moon, a couple of years later, landing on the moon. It's not just NASA anymore, right? Our commercial partners and all the ventures with SpaceX and others, we're going to have humans in space, not just by government agencies, but private sector as well, and maybe a decade or two from Mars. What are we doing, Jim, to protect the astronauts from that harmful solar radiation that we're going to be predicting? What are you guys doing?
All right. So, yes, we are going to be protecting our astronauts. And in fact, any young people out there, y'all interested in astronaut, we're going to make sure that you're safe out there as you go, all right? People like myself, we're too old. It's too late for us. But for the young groups that come on, we're going to be protecting. How do we protect it? One is we do a deep analysis. We work very closely with our friends in Boulder, understanding what the environment is. We have many models that we run. And so we do a deep analysis, but then we also do other things. As Bill mentioned, there are various aspects of radiation. There's the very energetic particles from the sun. there's a lot of material science investigations that are going on, and engineering to try to understand how can we protect the astronauts from the energetic particles. There are also cosmic rays that come that are generated extragalactically from that enter and over a period of time. Those are the ones that for the long period of time, if we send astronauts to Mars and back, it's going to be months at the very least. And so that cumulative dose of radiation is something that we're very understanding how we can protect that. We also do, when there is an alert going on, and we see that an event is getting ready to happen, that we've been told, there are places like on the International Space Station, there are places where there's I'll call it a safe closet, where all the astronauts go into, and that provides a lot more protection. For the Artemis program, they're going in these large capsules and orbiting the moon initially and eventually going to land in the moon. Right now they're already practicing. If they're en route to the moon in the capsule, there's a place for them to go to protect themselves. And so understanding the nature of the event, whether it's energetic particles, whether it is galactic cosmic rays, whether it is just intense UV radiation, we have these various protocols, and we put the astronauts in the safest condition, and they right now we don't we don't believe that there's going to be any issues, just because we have enough technology to be able to and operational procedures to be able to save the astronauts. But anytime that they are in space, we are observing and taking into account the great observations and alerts that are provided by NOAA, and all of the models that are being developed and continue to evolve, so that we can provide the best information to the astronauts for them to take the procedures, the actions that they need to have. Furthermore, as we get ready to go to Mars, we're going to be so far away from the Earth, they're not going to phone home and say, hey, is it okay for me to go outside and check this solar panel or something? No, they've got to be able to do that on orbit, in place. And so part of the activity right now that we're working across multi-agencies is to understand how can we develop an Earth-independent space weather capability. Because especially as we establish a permanent presence on the moon, and then eventually on Mars, Mars is not always aligned with the Earth and the Sun. It's going to be off on that side over there. And so that's the long future, especially as we have commercial entities, private entities going out, understanding how best to protect those folks, not only at the moon, but at Mars is very important. So with that, I'm going to ask, are there any other questions? Do we have, yes?
A couple things that I read that I thought were interesting. One, if you were going to be on the surface of Mars in the absence of some kind of advanced spacesuit, I read that you need to be surrounded by something the equivalent of like 6 feet of concrete on all sides to protect yourself from the radiation. And two, I read if we're ever actually going to land on Mars, we actually need to somehow get a satellite in orbit around Mars that we will fly to, and then fly down from the satellite to Mars back and forth. Talk about both of those if you can.
All right, so the first thing is that if you're going to be on Mars, you're not going to be outside without a sophisticated spacesuit. They are all going to have very sophisticated spacesuit, but it is exactly right. And one of the things that we are observing, or that we are beginning to think about, and we're looking at this on the moon also, there are these lava tubes that are left over from, a geological kind of activity on these various bodies, and going inside, it's basically like a cave. Going in there provides that deep protection. And so looking for that sort of thing on Mars as well would be very interesting. Also, there's an activity called In Situ Resource Utilization, ISRU, where we're looking at how can we take the lunar dust or the Martian soil and essentially make cement and be able to make building blocks to protect. And so maybe you build an igloo or something like that. And so those are the types of things that are being examined to understand. One of the things that we have that we do believe right now, or we understand, is that one of the better radiation protection is actually a large layer of water. Imagine that. So you go to Mars inside a swimming pool or something. I don't know what. But the point is, water is a very scarce commodity, obviously, and so even though water is a great shielder for these energetic particles and radiation events, that may not be the most practical. So, building structures out of the soil and the lunar activity or the Mars dust is something that's being looked at very seriously. You have a question?
I can bring a light to you real quick. I know this won't be in my lifetime, but as far as like terraforming Mars, what do things look like?
So obviously that's kind of perhaps the next step, one would imagine, especially if we're going to establish a permanent presence there. One thing that we are also, as we look at terraforming on any place that we might go, one of the highest priority is also planetary protection. So we want to ensure that we don't go someplace and we'll mess it up with our presence, okay? That's also a big deal on the moon right now. We're trying to understand if we're going to go back and establish a sustained presence, how do we protect that pristine environment for future generations to study that environment? We don't want to contaminate it in that way. So that also plays into terraforming. There are a lot of thoughts have been put into that before we actually get to that point, but that is clearly part of the thought process. Yes, sir.
I can run the mic. Are we having to deal with anything?
You gotta hold it up.
Are we having to do with anything with ozone now issues? With more countries being involved in refrigeration units, the gases, are we seeing anything getting worse in this century?
With respect to our atmosphere.
You're talking about really the atmosphere, so I'm just curious about, are we still looking at protecting ours?
We've completely given up on ours, not just that, of course.
No, there are more people that live on this planet than any place else. So yes, we are really taking strong care to look at those problems. I mean, and listen, I kind of make a joke about it. It's really complex. This is not an easy problem to solve, and considering the technologies that we are developing and the things that we want kind of for ourselves, but what are the overall impacts? And yes, we are looking at that very, very closely. NASA kind of does it from the research perspective. NOAA does it very much from the impact perspective, and so absolutely, and it's not only the U.S. government. We are working with other governments to monitor and to ensure that we take care of the environment that we have. I mean, right now, this is the only place we got to live, and we got better take care of it. So, good question. Any other questions? We still got a few more steps on his to run the microphones back and forth. Here, Bill.
Just while we're on the theme of biological effects of people. Now, the question has come up a lot about the eclipse, whether it affects animals. We talked a little bit about that this morning. But on this subject of space weather, there's an interesting piece I just wanted to share with you. When we do get the big eruptions from the sun, and they do impact Earth's magnetic field, it does have a profound effect on some animals. Now, it's very interesting. In Boulder, at the Space Weather Prediction Center, we're sitting there, we issue alerts to the power grid to keep the lights on. We're talking to the satellite operators. We're working very closely with communications and emergency responders. But the one I fear the most when we get the forecast wrong is the pigeon racing community. Believe it or not. Any pigeon racers out there? I have to be sensitive because I don't know much about it, but I did some research and wow. So when these folks get together, they can go up, maybe over to Santa Fe, and they'll bring the pigeons, and we'll have a kegger and a barbecue over there, release the pigeons. What do the pigeons do when they're first released? They circle. They're getting their magnetic bearing. And as soon as they figure out what's happening with that magnetic field and where they're at, they go home. they're able to track the magnetic field. And that all works great most of the time. Not so much during a geomagnetic storm. And it doesn't really have to be a big geomagnetic storm. So when we get those CMAs, hits the Earth's magnetic field, we have a scale of 1 through 5 for the storms, kind of like the Gita scale for tornadoes, right? If we're at the 2 level, they start cancelling these pigeon races. They call it a pigeon bus. The pigeons can actually get lost during it. They just can't track their way home. These guys would call it, he's so upset if I blew the forecast. I could never understand. It's a pigeon, why are you so mad? In an auction last year, one of these racing pigeons sold for $1.2 million. Now I appreciate why they get so upset if we get that forecast wrong. And just one little other piece to that story that was cute. I got a call several months ago from a wedding planner that wanted to sign up for the geomagnetic storm alerts and warnings. Now, why did the wedding planner want that information? Releasing the doves, right? Same thing. So she heard about it. She read it in one of the magazines. So she appreciated the effect it could have on her doves. But I had to ask her that question. I said, let me get this straight. So you're at the chapel. The bride and groom comes out, and the phone rings, and it's Phil Murta with a geomagnetic storm alert. You're not going to let them doves go? And she said, I guess not. I said, okay, because I want to be there. When you tell the bride that you didn't let those doves go due to a geomagnetic storm on her wedding day. So it's just an interesting side piece on the effects of space weather, because we concentrate so much on space weather and how it affects the technology that we rely on and use every day, but it has some very other interesting effects. And there's a lot of research on the way. You hear about these stories about whales getting beaching and whatnot. Is there any connection? We're starting to see and believe that yes, there are some connections with the sun, with the eruptions in the sun, how it affects the Earth's magnetic field and affects migratory animals. It's a real interesting area of study. So, next time you guys hear about the aurora borealis being visible across the United States, think about those poor pigeons.
All right, I'm going to go out and catch me a pigeon and see if I can sell it for $1 million. All right, any other questions? That was a great story. Yep, here we go.
Is there any connection between all of the climate issues that we're having on this Earth and around this Earth and the natural solar energy that we get and the studies that you guys are doing about the sun and its energy potential? What's the bridge connection there?
All right. Okay. Thank you. So the question between essentially the connection between space weather and climate change. Space weather, really, these events that we talk about are very short-lived. You know, they may, if they last, 4 days with a large geomagnetic storm, and so that's probably not going to impact climate in a measurable way as we measure. However, we certainly understand that the history of the sun has gone through various periods of dimming and less active periods of time. There's a period called the Maunder minimum, where rivers have frozen over that normally don't. I think the Thames in London or England is one place. And so understanding those very long-term, perhaps secular variations of the sun undoubtedly do certainly have an impact on temperature. The other much short-lived activities of the sun, even the 11-year solar cycle that we go through, and we're getting ready to go up to solar max, we're beginning to see perhaps some indications of a kind of long-term climatic impact, but those are
There's so many other variables that go into understanding what is causing our climate to change in the way it is, that it's really difficult to disentangle. So the point I'm making here is that we don't have the full understanding of the full climatic changings that we're observing to really understand how much of it is due to small-term solar variations that are usually associated with space weather. So I know that's not a very crisp answer, but I think I'm just trying to be transparent in terms of the state of our science, and quite frankly, it just lends itself to the fact that we just still need more research. And so that NOAA and NASA and NSF and many other agencies are putting resources toward better understanding those activities. Thank you. Okay. Any other questions? Is the moon still doing its job out there? Since we, yeah, okay, good, all right. We're not to the Ring of Fire yet, are we? 10:35 local time. Okay. All right. Okay, we got another few minutes. Okay. Any other questions? Oh, I'm sorry.
How many space assets do we have observing the sun? We can just repeat
Okay.
the question.
How many space assets do we have observing the sun? Oh my goodness.
We have 16 operating missions.
We have 16 operating missions in heliophysics alone. Earth science had, I don't know, I'm going to venture that we probably have 70 missions out there that are making space observations. And the fact that they're making space observations, they are impacted by the sun's activity. So I'm going to say that every mission that we put out there is observing the sun in some particular way. Not most of them are not imaging it, but we certainly pay attention to the space environment in which they're in, which we take driven from by the alerts. And if there are anomalies that occur, we try to trace it back oftentimes to the sun's activity. So, but we have 10 or more very directly imaging the sun all the time. We've even had a mission that went and observed the far side of the sun. Many people think it's the dark side. It's not that. It's still shining on that far side. So stereo, actually, we had 2 spacecraft do. Yeah. It's just not facing us, but it's shining on the bright side, on the far side as well. Did I get that, Heather? Okay. All right. Okay. Any other questions? All right. I'm sure you got one.
Well, I'm just saying this because we have about 5 more minutes with the 3 of you. And a question that I asked earlier that I think is kind of interesting, that, actually trying to land on Mars and fly to Mars, we couldn't actually fly straight to Mars and attempt to land straight on Mars from a direct shot, right? Like, somehow we need to stop up there or orbit and then come down.
But yeah, so any landing on another planet, you're gonna have to have a. It's like when you're flying on an airplane. You don't go flying, you just go crazy. You kind of have an approach and you come in and you land in the way. And so you think of it that way. Yes, orbiting, particularly if you want to brake, use the atmosphere to kind of slow you down a little bit before you get nearby. So all of those sorts of things. There are different orbital options to go to Mars. Some are a little bit more direct than others, but all of them involve some sort of capability to slow down before you get there, and oftentimes we use the orbit insertion type of activity to help slow you down. All right. Well, I'm going to turn it back over. Thank you so much for your attentiveness, and I hope that it was useful information for you.
Yes, we have 8 minutes here. The next speaker will be up at 10:12, but we've got like a good 5 minutes to just enjoy the eclipse for a little bit. If you want to go take a look, we have fresh sets of glasses.
Technology. It's the rhythm of our everyday life. We're more dependent on satellite and communication systems than at any other time in history. Disruptions can affect our economy and even our safety. To prepare for the effects of such events and minimize impacts, we need to look outside our atmosphere, some 93 million miles away, at a star we call the Sun. It's our main energy source. It warms the Earth and grows our food. While the Sun and the space between may seem pleasant from our perspective, it's anything but peaceful. At its surface exists a chaotic state of eruptions and radiation. And unlike Vegas, what happens at the Sun doesn't stay at the Sun.
Space weather is essentially emissions from the Sun, radiation, magnetic field that erupts from the solar surface, pumped out into space, sometimes right towards Earth. When it impacts the Earth, it impacts our technology. That's what we call space weather.
These solar events and their effects at Earth can disrupt systems we take for granted. From causing blackouts to the power grid, to delaying offshore drilling operations due to inaccurate GPS data. Interference with communication systems can force air traffic to reroute and impact rescue response and coordination. Outside our atmosphere, solar radiation can harm astronauts and the systems they depend on. The good news is that these eruptions can be detected early. Forecasters at the NOAA Space Weather Prediction Center in Boulder, Colorado, have their eyes on the Sun at all times.
The Space Weather Prediction Center is part of the National Weather Service and is very much like a normal weather forecast office. We're here 24 hours a day, 7 days a week. We're looking at data, we're looking at imagery, we're looking at model outputs. As conditions develop, we put out alerts, warnings, and watches of imminent activity to our customers so they can take action.
In many ways, forecasting space weather is a lot like forecasting hurricanes. Those who rely on space weather forecasts, like electric power grid managers, are informed early on and can begin taking protective action.
When we see an eruption on the Sun, space weather forecasters will issue a watch. And this is much like a hurricane watch. When a hurricane sits offshore of Miami, for example, perhaps 48 hours out, we too can see way in advance that something may be coming towards the Earth.
As the storm moves toward us, it hits a monitoring spacecraft orbiting 1 million miles away from Earth.
It's kind of our buoy sitting out there offshore, and that hurricane, about 30, 45 minutes before it makes landfall, we'll get the measurements from the buoy. That's what the spacecraft does for us. That big eruption that left the Sun hits the spacecraft. Now we've got the measurements of exactly what's going to impact us here on Earth, and we issue the warnings to give the power grid a heads up that the storm is now imminent. An interesting element to this whole process is that when the forecasters issue the alert, the power grid receives the alert, takes the necessary actions to protect the grid, the average citizen never knows anything ever happened.
The number of customers who rely on space weather information continues to grow. As our reliance on technology increases, so will our need for constant monitoring of the Sun.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in the near-Earth space that can affect our technological infrastructure and society. The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather. The Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth. But we see solar storms almost all the time. And these storms have an effect on our technological infrastructure. Solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communications, and can cause our GPS navigation to fail. NOAA is working with its international partners to ensure that we have different vantage points where we can observe space weather. Our space weather observing infrastructure from space includes the NOAA Discover satellite and the NASA ACE satellites that are stationed upstream of Earth to give us a first buoy measurement of the solar wind. It also includes the ESA-NASA SOHO satellite and the NASA Stereo satellite that image the sun and also make coronagraph measurements of the outer atmosphere of the sun, the corona, that can tell us when large explosions happen off the sun. We also observe the sun and the Earth's magnetic field from the geostationary location with NOAA's GOES. So the way we use this space weather information from satellites and from the ground is to be able to make forecasts and predictions, just like we do with hurricanes and terrestrial weather. We observe the sun and look for activity and see how it develops, and see if it's going to culminate into a large explosion that can affect us here on Earth. NOAA is working with its international partners to expand our observing capability. We're committed to observing along the sun-Earth line. So we're going to do the imaging of the sun and the upstream buoy measurements of the solar wind along the sun-Earth axis. The more we understand about the sun, the more we can prepare for it and become, just like we are a weather-ready nation, become a space weather-ready nation. And as we look forward to humans exploring out into the solar system and advancing our space commerce activities, space weather becomes more and more important.
Next here to share a presentation with us, later, League and the. So we're going to here with us.
I care about the upper regions of the ionosphere. Eric is all about the lower regions of the atmosphere, closer to the ground. What we care about as ham radio operators is we send a signal, and there's a tent over there with a mast, an antenna mast, and some wires connected to it, and we're sending that signal up into the ionosphere where it's refracted, not reflected, refracted back down. Where? Well, we've been testing it today, and it's been received as far away as Hong Kong, up the east coast of Asia, across into Alaska, all over the US and Canada, and then as far east as the United Kingdom. With that transmitter right over there in that tent. And we've been doing it in Morse code, by the way. So amateur radio is still alive. And what we're doing here is we're having a ham sci, ham, which is short for amateur radio, science. Obviously, we're talking about science here. And so what kind of impacts do we have? Next slide. Let's go. Oh, do I have a button? Oh, I have a button. A clicker. And it works. So this group of ham scientists, mostly guys and gals who are in colleges and universities around the U.S., many of whom are amateur radio operators, got together and said, you know, we can do science with ham radio. And where it really came to fruition was the 2017 total solar eclipse, when my wife and I and grandson number 2 and his friend went to Lander, Wyoming to do some experiments up there. So we're doing it here now. And we do real scientific research. We provide data, and from the data, the analysis shows how we can improve models that predict high frequency. Okay, Eric? We had a chair collapse back there. How we can predict propagation and where we can work around the world with our radio signals. So, you've seen some pictures already today of what the eclipse is about. 3 heavenly bodies, the sun, the moon, and the earth, get in the right position. Lo and behold, the sun seems to mostly disappear. Because of the relative positions, it doesn't completely disappear like it will on the April 8th next year. We're going to have a total solar eclipse, but you're going to have to go to, of all places, Texas or elsewhere in the U.S. as it exits through Maine to see that one. So, what's cool about an eclipse is just like what happens day and night. Right? Approximately every 12 hours, exactly, almost, when it's the equinox twice a year, the sun rises and the sun sets. The cool thing about an eclipse is, through science, we know exactly when these events will occur, so they're controlled experiments. We can look at time and look at signal strength and see how the eclipse affected that signal strength around the world. So, the difference, the sun has different cycles. It has an 11-year cycle, a 22-year cycle, and what happens is the irradiation upon the Earth of mostly ultraviolet light, that's what affects the upper ionosphere, changes in intensity. And we're getting up close to the peak of the current 11-year cycle, probably occur in 2025. And you can see the progress, cycle 25. Cycle 24 was dismal. Radio HF propagation was mostly bad most of the time for the entire 11 years, rather than just at the nadir or the bottom of that particular cycle. So we're hoping for, and in fact this past week we've had some of the best propagation we've had in 20 years. It's really been wonderful. Here are the paths of the eclipses. You can see this is the one we're currently in. Entered the U.S. already in Oregon. It's headed our way. It's going to go around San Antonio, Texas, before it exits exits into the Caribbean and goes across into South America. By the way, this and the one in April of next year are the last two we're going to see. We'll see no more this decade in North America. You'll have to go elsewhere. Now, this is a diagram of what the ionosphere is. When the ultraviolet light hits our upper atmosphere, that provides energy to atoms, and the electrons are released from those atoms, and so you have a positively charged atom missing an electron and a negatively charged electron. Those are called ions. And those ions, with sufficient density, can refract or bend radio signals of a certain frequency. There are different layers. The upper ones are the F1 and F2 layers. The next one down, the E layer, and the bottom one, the D layer. And what happens between the day and night signal, the upper F1 and F2 combine, the lower E layer and D layer combine, and the intensity, how thick they are virtually changes, and that changes how different frequencies are refracted around the Earth. And here's somewhat of an example. During an eclipse, the same thing that happens at the day and night cycle will happen over a relatively short period of time. So in some cases, and we're doing different frequencies at different times there, our lower frequencies aren't going very far. We're being heard in Tucson now, and that was all. Whereas at 6 o'clock this morning, we were heard in all the surrounding states and beyond. And the upper frequencies, we weren't heard anywhere yet until the sun got up, irradiated the ionosphere more, and the F1 and F2 layers began to work for us. So that's all going to happen in a short period of time instead of taking 24 hours to occur. The cool thing about it is we can predict how much radiation is going to occur in the ionosphere and then expect those results. Now, there are things that happen. I just had an interesting discussion with one of your scientists here a little bit ago about things called coronal mass ejections, where the sun ejects a huge amount of material. And if that's Earth directed, it does bad things to the ionosphere, and our signals don't go anywhere except along the ground. We can't predict when a geomagnetic storm is likely to occur. Based on sunspot sizes and counts, we can say the probability goes up, but we won't know till it happens, and that's a surprise. We don't like surprises. Anybody in science does not like a surprise. There we go. So what are we here for? We're making contacts with other stations, but mostly we're transmitting so that our signals can be decoded at receivers around the world. The receiver hears our Morse code, the software on the computer decodes it and says, here's K8TE, that's my ham radio call sign, at this time, on this frequency, at this strength. And so all those data are being collected every time we make our transmissions. And at the end of this event, all the data will be downloaded and will go to the people who are way smarter than I am at those universities, who will then analyze the data, correlate it with the radiation from the sun that was blocked by the moon, and they can improve propagation prediction models, which we care about, and so do many others. The military is actually a heavy-duty user of high-frequency propagation. So, hundreds of hams are out around the world doing this right now. We've already logged a bunch of them, and we'll probably log more through the eclipse and then beyond the eclipse, so we have data before, during, and after the eclipse. In 2017, we did this very successfully. Had a whole lot of fun up there doing it in Lander, Wyoming. And here's some results. These are the number of contacts that I made, mostly in Morse code. Why? Because Morse code can be automatically decoded by a machine, a software-defined radio in a computer. And of course, we decode it in our heads, and we type in the call signs and their grid square. Where are they located on the surface of the Earth? And the whole Earth is divided into grids with alphanumeric characters that tell us where they're located. So, lots of logs, 566 logs sent in. Here's the cool part about it. Different networks, the reverse beacon network, the weak signal propagation reporter network, and PSK reporter, using digital signals, we literally had almost 2 million data points to analyze. Pretty cool stuff. This is unpaid people interested in science. It's happening out there. So, who ought to do it? Well, we like other hams. How many of you are a ham radio operator? We need more of you. There's one. Congratulations. Welcome. Bienvenido. We need more of you. It's too late for this one, but hey, April 8th, 2024, there's going to be a total eclipse, and your information, your communication will be useful in analyzing the data. Here's a typical fancy station in western Pennsylvania, Tim Duffy's station. I know Tim well. He owns a big company that sells radio gear, and we like to buy radio gear, don't we, darling?
Bill, 1 minute.
1 minute, okay. Here's a transmitter running 1/4 of a watt hooked to an antenna that can be picked up around the world. This is the kind of stuff we do with relatively inexpensive equipment, and we take it seriously. Someone will operate this 24/7 for a month to test antennas and propagation. So we're here doing it, we're doing science, we're going to, who knows what we may discover. That's the cool thing about science. Accidents happen. By the way, I was just listening to some guys talking about weather prediction on the ham radio, and they had no idea how accurate you guys are. Why? The more data we collect, we put it into computer models, and it becomes more accurate, doesn't it? So we do the same thing for HF propagation. Thank you very much.
Bill Mader, ladies and gentlemen, thank you very much for your time. Fascinating presentation. We're going to hand it back over to Dr. Biesicker right now, and you can keep your
It is every day you get to see the governor, but this is one of our brilliant, and it showcases the beauty of our incredible skies and our landscape, and it reintroduces the whole world to a beautiful, multicultural, diverse state with, I can do it as the governor of New Mexico, the best people in the world. So we invite you and want to keep this going. Two, we're really showcasing the art and science, right, that New Mexico is frankly known for. The only land-based spaceport in America. We had some of the earliest space programs in America, and a lot of that tech and science is developed and delivered right here from New Mexico. And now, thanks to NASA and NOAA and all of our national and international partners who are engaging not just the world in science by virtue of this eclipse, but they're engaging young people, New Mexicans and our visitors, in STEM and science and math, and just the wonder of understanding an eclipse. And I'm getting information about how fast the moon is traveling, thousands of miles a minute. It's incredible, and that this was one, if not the best, place in the world today to see this eclipse. You can still, so if you're in New Mexico somewhere, you can still view the eclipse. The peak area for Albuquerque has ended. We're seeing that ring of fire now abate a bit, but it is still a remarkable phenomenon. And I want to leave you with this. Not just congratulations to everyone, a shout out to our science partners, but this. This is a state about wonder, about learning, about innovation. And today marks another successful journey in all of those three aspects. New Mexico, never stop wondering, never stop innovating, never stop learning. What a special day for me. Thank you, everyone.
And I only meant in person. We don't get to see the governor in person very often, so what a special moment for us here. So thank you for stopping by and saying hi. We are not done yet, though. From what I understand here, we also have Congresswoman Teresa Leger Fernandez here, and we want to give her a moment to come up and say hi too. Another person we see on TV all the time, but in person not very often.
Hello! This is so absolutely marvelous. Like, I need to tell you, I made sure that I got on the last plane back to New Mexico last night from DC so I could be here for. And I really want to thank Nan, who runs the Balloon Museum. I want to thank Shell Sanchez, who's the director, because look at what they did. They brought us together in community so that we could stand in awe of nature, so we could stand in awe of what is happening in our solar system. And NOAA, the National Science Foundation, they are there to help take that awe and that curiosity and take it to the next step. Make sure you follow them. Make sure you see and get their stuff. It's like, what's the next amazing thing we're going to see in our sky? But the other thing that they do is they don't just help us wonder why. They help us protect today. So those solar, I just learned all about, the solar flares. Well, we think they're magnificent and amazing, and there's that fury and that energy. But that beautiful fury and the energy can also destroy. So we need to thank NOAA and the work they are doing to make sure that we can use these phones of ours. So give it up for NOAA. Woo! Give it up for NOAA. Give it up for the Balloon Museum. Give it up for the National Science Foundation. Give it up for the Museum of Natural History. Thank you for making us wonder and for teaching us every day the glory of our solar system. And like New Mexico, it can't be better anywhere than here, because who does Balloon Fiesta plus solar eclipse? Only in the land of enchantment. Muchísimas gracias por compartir todo esto con nosotros. Gracias.
Hey, and it's important to look good against in front of a member of Congress, right? Because we got to remember who makes the decisions about spending when it comes to this stuff. So we may need more money for things. So thank you. Yeah, that's right. Okay. So as we continue to watch this annular solar eclipse hit its second half, we're continuing to watch this eclipse reach its peak stage in other parts of the world right now. It's a real fun thing to watch. We're going to transition to a couple of other speakers who are actually going to get us ready for more eclipses here. This is going to be fun, I think. First, we've got Patty Seaton. Patty is the director of the Owens Planetarium in Lanham, Maryland, and she's going to be joined by April Witt, who's the director of the Fernbank Planetarium in Atlanta, Georgia. Totality 2024, yeah, next year is going to be another big year for eclipses. So let's get the two of you on stage here. I feel like we're in for a good show right now. All right.
Thank you.
Thank you.
Woo! All right, well, we'll correct this a little bit. So my actual title is Planetarium Specialist, and April is?
Retired.
But you can
spare time. We're good to do the fun stuff.
Yeah, you can take an educator and retire, but you can never. Yeah, she's always going to be an educator. So I'm coming in from Maryland. Thank you, New Mexico. Woo!
Is this awesome? Was this anybody's first eclipse?
Yeah, who's here for the first? Who's first eclipse? Yay! You're 1 for 1. Look at that. That's awesome. So you came here. This is you. This is you. And this is coming. I know. I wonder if I can. Ooh. Yes, it does. Okay. Oh, this is much better. Okay, so this is coming. So we're going to try something a little bit. This wasn't annular. You had to wear your eclipse glasses the entire time. You did it right, correctly. Yes? Yes? Woo! Now, there's a little bit different come April, but notice, does this path look like it's going through New Mexico? No, so you're going to have to travel. So there's a couple people, as Kyle said, that in Texas that paid off the world so that they'd be able to be in one place for both eclipses. But let's talk about the differences. So I want you to try this. I want you to pretend that my wonderful colleague, April Witt, is the sun. And you are going to try to represent the moon and the earth. So I want you to try this. Put out your thumb. Your thumb is the moon. And I want you to try to cover, right now at it fully extended, can you cover April's face? No. So now I want you to move your thumb until you can fully cover her face.
How do you have to pull it? Sorry. How do you have to move your arm so that you can cover the face? Do you pull it toward you or away?
Yep. Closer or farther away? What do you have to do to cover her? Yeah.
Closer. Okay.
Closer. So why is that? Objects that are closer
appear larger.
Appear larger. So that's what's going on. Our moon does not orbit in this beautiful hula hoop circle. It's actually a little bit of an ellipse. So today, it was more like your thumb was out here. In April, it's more like your thumb is right here. So how to get ready for totality, and how else does this work? Oh, apparently I can move the clicker. So I'm going to give both orbits to April. And I'm going to pretend that I know what I'm doing with this. Is this what I'm supposed to be using? Oh, he knew how to do it because he was better than me. All right. So one of the cool things about studying and making observations in science, because we are both teachers, I guess we didn't really talk about that, so is that observations allow us to make predictions. So that's how we knew how to be here today and see the annular eclipse, and that's how we know where to go to see other eclipses. So this is the total and annular eclipses, all these wonderful images from GreatAmericanEclipse.com, so you can go and get these images. But we're going to talk a little bit about why does this not happen all the time?
Exactly. So, anybody know the name of the phase of the moon when it's covering up the sun? We're seeing the dark side of the moon that's a midterm. You know? Yes. Excellent. Woo! 10 points.
I wish I were your teacher. Awesome. Go back and brag when you go back to school.
So when the moon is new, it's between the Earth and the sun. But isn't there a new moon every month?
Every month?
Every month. Yes, there's a new moon every month. So how come we don't have an eclipse every month?
because we're not like people text us to pay them to, no, okay. That doesn't really happen. That's not scientifically accurate.
Hold this a second. Okay.
Yep.
Okay. Okay. So the orbit of the
This one's
Earth,
better.
the orbit of the Earth, not right to scale, okay, and the orbit of the Moon, but they're not right on top of each other. The Moon's orbit is tipped a little bit. So as the Moon goes along its orbit, sometimes where the orbits cross, that's where you get an eclipse. And sometimes the Moon is at just the right place and it's right closer along its orbit than usual, and that's when we get a total eclipse. April 8th, next year, be there or be square. This year, we had a new moon when it was a little farther away, like Betty just said, so we didn't cover quite the whole sun. So there's a new moon every month, but there's not an eclipse every month because of the tilted orbits.
It gets complicated real fast, so models we find really help you, and I'm going to put in a plug, so if you really want to see a good model, come into the little portable planetarium that is right inside the Balloon Museum, right there. Come check us out in there as well. So, let's move forward about it, because we talked about predictions, right? So now I want to get your feedback on this. So, there's this awesome place about 3 hours from here, Chaco Culture Natural Historical Park. How many of you have been there? Yeah, I'm glad to see a couple of hands. Well, one of the most amazing things is there's some ancient Hawaiian ruins there. If you do go there, I'm going to ask you to be mindful. When you go there, respect what came before. When you're looking at ruins, you're seeing a culture that was once thriving. And you're experiencing something amazing. And they've left some records behind. This is like their graffiti, right? No, they didn't do graffiti. They weren't bad that way. But what does this image kind of remind you of? What do you think? Kind of reminds you of the sun. And if you had a chance to look through some of our cool hydrogen alpha filters through our telescopes, you might get to see some of these prominent things going on the sun. It's pretty awesome. So this looks like the sun. So, but can you just look up at the sun and see those without those special glasses and stuff? Oop, I guess I got out of the range. Sorry, bad me. Are you going to be able to see these without a special filter on a telescope? No. So how would the people who lived in this area in around the year 800 to 1100 AD, how would they have been able to see this? Well, if you get to a total solar eclipse like we're going to have in April, you can actually see the solar curvature. You can see the atmosphere of the sun. You can see the cool things happening. So is it possible that they could have been recording a solar eclipse? To do that, you got to do a little bit of homework. Can we go to, oh, you're good. Oh, I did it myself. I'm so excited. Do a little bit of homework. Could it look like that from far away? So here we've got a nice NASA image. They've got spacecraft that cover the sun so that they could see what's going on. Yeah. Oh, we're just switching out names. Hand drawing right here, which is showing us even really cool more things happening. And then this petroglyph was in the year 1097. So actually, it wasn't 1097. 1097, we know because we can predict backwards and forwards when eclipses happen. There was a total solar eclipse that would have been visible from the Chaco Canyon area here in New Mexico. So is it possible that they could have seen it as well? This is a theory because we know that if the sun's covered like that, we'd be able to see those fancy prominences. Does this kind of look like the drawings? What do you think? We don't know, so we're just guessing. And one way you can prepare for the upcoming eclipses is that we do have some tactiles. So if you know some friends that are not able to, are visually impaired, they can feel the phases of the moon, they can feel the solar prominences. I believe we still have some, again, at the American, say it right, Natural History Museum table, right over this way. We have some of these that you could take home and use it. Touch, experience it with all of your senses. All right, now let me get back to that last little thing about could it be? Could it be? I don't know. There we go. So another thing that makes this suspicious or gives more evidence to the fact that maybe this site could have been a sun watching site for that solar eclipse is that it is also the way that it's oriented. You've got a really awesome view of a sunset and sunrise. I think this was sunrise, Eastern, so that must be sunrise. So this is right near the summer solstice. which is the first day of summer. You've got a great horizon for observing the rising of the sun. And then come over here to the western part, same thing. You can use the horizon around you, and you should do that if you live here in New Mexico. You got some, amazing mountains right there. Use the positions to predict and know when the sun's rising and setting and what season it is. So normally a sun spot like this would help indicate that this is a sun watching site. The cool thing about this particular petroglyph is if you go down to Chaco Canyon, you don't have to go far. It's right outside the visitor center. So you can visit that and make some predictions. So I know our title said that we were supposed to get you ready for the upcoming eclipses, but we wanted as educators to have you thinking about how we do this, how things work, how we make predictions, and you've got some really good advice, don't you, April?
I do, but I want you to back up one slide for just a second.
Oh, I think I can use this properly now. Nope. Ta-da!
Okay. If you look at that really carefully, the NASA image, that's right now, right? The image that's in the center, the drawing, that could be from the 1800s. There was not photography, there were not great telescopes, or telescopes, but it was hard to see, get into a solar eclipse. Way, way, way long time ago, how do you record things? Maybe pick out on a rock with a petroglyph. So the technology that we have today that we just simply take for granted, we knew what time this was going to happen. We knew where to be. We knew what to use in front of our eyes to be safe. We can do that now. But if you think of how people did it a long time ago, that's just totally cool. But like Patty said, things to remember. These filters, they can work every day.
Come to here. Oh, podium? Oh, come closer to the podium because
Okay.
because you have one too.
Online audience is at the podium.
Thank you.
Okay, am I good? Okay.
Yeah, he said
You
the
don't-
online audience is there. So,
Okay,
yeah.
so you don't have to wait till April of 2024 to use these. Check the sun occasionally. Make sure you're using them properly. You know how to do that, right? You look down, you look up, you look down. Do not do what I did this morning and say, oops, sun. Make sure that you're using the right thing. You want to keep these, you don't want holes in them. You don't want them scratched. If you wrap them up in a piece of paper, put them in an envelope or something, keep them safe till next time you use them. You want to make it, I don't know if you noticed when the sun was almost all covered up. When you looked at a shadow, look at the shadows now. There are shadows
So
over
much
on the
brighter
shadow
now.
chairs. Yeah, it's brighter now too, more sun. Nice crisp shadows. During totality but before totality and when the annular was going on, the shadows were fuzzy along the edges. You don't get to see that very much. It was hard to hear the different sounds. That sound is going, we hear that all the time. When totality happens, when the sun is covered with the moon and it's really dark, and all around the edges is yellow light like the sun is setting all around the whole horizon, keep track of that. And it's really, really hard during the eclipse not to say, wow, but look around, see what other things are going on around. Listen to how the sounds are changing. Another thing is, taking care of the glasses. Excuse me. And the temperature change. Anybody know? I think it's cold here. I'm from Atlanta. It is cold here to me. When in April, when the next eclipse is, watch how the temperature changes as the eclipse is going on. When totality happens and the temperature drops and it's cold really fast, and if you have one of these, phone. If you have one of these,
Nobody has any of those.
Nobody has one of these. There's an app from NASA. It's called Globe, Globe, like a globe of the Earth. And it has an app where you can watch the eclipse. As the eclipse is going on, send data to NASA. They want to know what the temperature is. They want to know what the time is. That's going to help a lot because they're also using satellites to watch what's going on. But human eyes are a little more accurate than satellite eyes. Satellites have a hard time telling the difference between land and water, for example, where the edge is. Human eyes are better at that. So you can help out by using the NASA Globe app. Please do. I'm doing the cloud one, and in about 10 minutes I have to go to a recording.
So I guess we're supposed to have questions. Is there still time for
Any
us?
questions?
Are there any questions?
Are there any questions? You
Well,
guys are
keep
awesome.
watching. Oh, question! Yay! We love questions. Oh,
I'll bring
would you
the mic
like?
out there.
Oh,
That's why I'm here.
do I have to put this back in? Yeah.
Do we know what the first total eclipse sighting was recorded is in history?
Ooh,
First total eclipse.
I don't know that. Do you? I think she does.
I don't know the time actually for sure, but the Chinese had recordings thousands of years ago.
Yeah.
So it's probably thousands of years ago. The thing of it is, you got to have enough people around that you're not starving and just barely subsisting. You have to have a big enough civilization so that there are people who have time to watch and record. So yeah, probably. Good question though.
That was a
We'll
great
look it up
question.
for next time.
Any other questions? Oh, okay, we're back here.
Yay!
A smart kid.
The kid I want.
Say it again.
When are you gonna be at the solar eclipse?
When are we going to be? April 8th, 2024. And where? I'm going to be going to right outside of Dallas, Texas, because I've got friends that live there. Where are you going to
I'll
be?
come with you.
You're going to come with me? I got Paul Kravinsky and his
Yes.
nephew,
Okay.
yeah?
Yep.
So that's where we're going.
We're all coming over as well.
All right, I'm going to tell Uncle Eric, if you're watching, we got a whole bunch of people coming. So, hey, thanks for giving us a chance to come up here. We are having fun, and again, come visit us in the planetarium because we'll teach you everything that you didn't know about what you just saw. All right. Woo! Thank you.
Thank you.
Thanks so much.
Well, we're running a little ahead of schedule, but I don't think there's any reason to stop going forward at this point. So while we did enjoy that presentation, and that was very educational, our next speaker is Dr. Alessandra Pacini. Alessandra is the NOAA space weather scientist and heliophysics data steward at NCEI in Boulder, Colorado. NCEI, it's another science acronym for us, but I'm sure she'll tell us exactly what that means. But she's going to talk about connections through eclipses. So, ladies and gentlemen, Dr. Alessandra Pacini.
Thank you, Larry. Yeah, it's good. Hello, everybody. Can you hear me? Can you hear me all right? Great. It was amazing, huh? So, I will be here on the podium talking about some connections, and I hope you all felt connected to space right now, looking at this beautiful event of alignment of the moon, the earth, and the sun. Let me see if I can pass. We already heard a lot about what is happening on space for connecting all these bodies and all these objects in space. One thing that you didn't hear much about was how can we look at these events from the space? And you know, at NOAA, we care about space weather. You heard that a little earlier today. And we have some satellites in space. Some satellites are orbiting the Earth, and some satellites are out in the solar wind between the sun and the Earth. And those satellites are measuring things that happen in space, but also looking down to the Earth and seeing what is happening in the Earth. So I put here in this image the orbit of the moon, and you can see the inclination that the teachers just mentioned of the orbit of the moon, and that's why we don't have eclipses every month. But you can see that one of our satellites is closer to the Earth than the moon orbit. And what happens if you look down to the Earth during eclipses? So you can see in this image here the eclipse, one annular eclipse that happened in 2017, and actually we were seeing from this satellite that is out in the solar wind called Discover. Discover mission is looking down to the Earth, and you can see the shadow passing. That was the shadow that passed right above our heads right now, a few minutes ago. And if you look from the other satellite, GOES, which is the closer one, you can see with even more details. You can see, you can infer how the temperature drops during this shadow passing. You can see things changing in the atmosphere and the oceans. So this makes us even more connected to these events on space, looking down through our satellites. So the connections on Earth, I need to see these slides. Yeah, so this is the picture of the 2012 event, Solar Eclipse Annular, that happened here in Albuquerque in 2012. The next one will be in 200 years. the next solar annular eclipse that is gonna pass in Albuquerque, we'll have to wait 215 years to see it again. So our descendants are gonna experience that, and they will see the ring of light, the ring of fire that we just saw. And what happened to the animals during eclipses? We felt a little bit the illumination changing, but not much, because just a little bit of sun, the solar disk, the light that comes from the solar disk is enough to illuminate us. So we don't feel much the difference in the light. But if you have a total solar eclipse, you really can see the dark coming. It's like becoming night for that minute. And the animals can feel that. So there are some reports of the animals getting more anxious or having behaviors of the evening time, which is very cool to see. Who here experienced the 2017 eclipse, total eclipse? Probably heard, yeah, I was in South Carolina and I could hear the crickets start singing and the birds, we could see them flying back to the trees. So that was really amazing because connect us to the other species on this beautiful blue planet and connect us and all of us, Earthlings, to the sun and to the moon. And these eclipses that we just saw is keep going. The shadow is keep going, just cross 5 states in the United States, starting in Oregon, it's gonna end in Texas, and then it's gonna keep crossing different countries in America, in the American continent, crossing Mexico and then Central America, then Colombia, and then my country, Brazil. It's gonna end in Brazil. So whoever is online watching us, keep looking because we will keep showing what is happening, and if you are in the trajectory of the annularity, you will see this ring of light as well. And that makes us connected through this event to different countries, different languages, different backgrounds, cultural. So this is very important. Everybody's looking up today to this event. We just saw the teachers mention the Chaco Canyon, that petroglyph. That was an eclipse that happened in 1097, and that was on the rock painted. So people here, ancient people, ancient civilizations that were in this region, they already experienced total eclipses and they recorded that. And that's also very cool to think that nowadays we look at the sun in modern technologies, and in the past people were already observing that. And those are connected. This is a NASA mission Punch, and they have this beautiful outreach program connecting the modern and the ancient views of the sun and the corona, the solar corona. There are other, I put here some other eclipses in the past that happened near the path of this eclipse that we are experiencing today. And we just for you to see opportunities that we have to connect education and some other inspirations events during these events. So here is an example that happened in Panama, where teachers from England, they came and brought telescopes just like the ones you saw today here, and they were inspiring kids with special educational needs. So that's a very beautiful program, and that was also an annular eclipse. And in Brazil, we had some other eclipses in the past that had scientists together with indigenous people, and they were together, they were experiencing eclipses and trying to get measurements for their experiments, but also having impressions of the native populations in that places in Brazil. That's a 1940s eclipse that happened in 2 different places. And this is a very important eclipse, the 1919 eclipse, that was measured in Sobral, in Ceará, in Brazil. And this was the eclipse that helped prove the general relativity theory that Einstein made years before. So that proves that the big mass can bend light. So we have the gravitational gravitational lens. Yeah, lens. So this is a piece of a newspaper when Einstein said that he created a question in his mind, and the beautiful skies in Brazil helped prove this, and through this beautiful eclipse. And you can see this eclipse happened during solar maximum. So we saw some prominence, like some filament of the sun in the edge of the solar border there. that the moon helped to cover the disk so we could see these brightness features, just without any equipment, just with the glasses, the Eclipse glasses and some telescopes. So today we were all connected. This event here was called Sun, Moon, and You. So I hope you all felt these connections through the space and bringing science and technology, and also all this local knowledge and these different people that came from the Balloon Fiesta with us scientists. So I hope you keep enjoying the event. Thank you very much for the attention. If anybody has any questions, you can go ahead.
I was going to say we have a moment for questions if there are any. If there are any questions, we do have a moment for it. You just let us know.
Thank you. No,
Okay, all right. This one may be difficult. Are you ready?
I know, I don't know.
That was a great talk, thanks. So
Thank you.
that last image from Brazil of the eclipse, you showed the prominence.
Yeah.
If we're lucky enough, come April, and we have actually got a coronal mass ejection underway during the full eclipse, what do you think that would look like?
Yeah, you'll be able to see. Thank you for the question, Bill. You'll be able to see during the eclipse next year, April, that is a total eclipse, that will be showing to your naked eye the solar corona. If something like that happens, or a solar mass ejection happens during that, and remember, we will be in solar maximum, very close to solar maximum, so those activities are gonna be happening. If that happens during the eclipse moment, we'll be able to see that with our naked eyes, because during the totality, you can take the eclipse glasses out and just enjoy the corona. So if you saw the 2017 eclipse, you saw how dynamic is all this corona. You can see these movements and all this interaction. It's really magical to watch an eclipse. And I really hope for CMEs, the coronal mass ejections in 2024. Thank you.
Does anyone else have a question? Perhaps not. That's fine.
Thank you.
We're going to keep that one up there.
Okay.
I think so, yeah.
Yeah, there is one that is back. Thank you.
All right, so I know that the show is in a sense wrapping up here in Albuquerque, but we are broadcasting online to actually to a worldwide audience. So we're going to keep going, and we're actually still watching this eclipse play out in other spots and still talking about it as it's going on. So the show is not done here, even though at least in Albuquerque we've witnessed most of this annular eclipse, which is really quite spectacular. So our next speaker here, I believe, David Hurd, is going to be coming up soon. All right, and here he comes on cue. David, welcome.
Thank you.
Thanks for being here. David, you are the planetarium director and a professor from Penn Western University.
That's
here
right.
Now, welcome to Albuquerque.
Good to be here. Good to be here. Okay, great. So I'm going to launch right into this. I got a question. I see the audience is huge here, so stay back away from the stage. Okay. Anyway, let's go back 44 years. How many paths of eclipses have occurred in the contiguous United States of America over the last 44 years? Wait, time out. What do I mean when I say contiguous United States? Help me out.
Lower 48.
Lower 48. There we go. How many eclipses have occurred in the last 44 years in the contiguous United States?
37.
37.
I said
7. Any other guessers? Try 6.
I was so close.
You were very close. So only 6 paths have been in the contiguous United States of America. 4 of them have been annular eclipses, like the one we observed today, October 14th, 2023. 2 of them have been total solar eclipses, okay? And we would have to go back. If you can look on this map, are you able to scan in on that map back there or not? That's a static picture, isn't it? So if you could see this map here on the board, if we go back to 1979, you'll see that there's blue paths and there's red paths. Yes, raise your hand if you see those blue paths and red paths. Okay, what do you suppose those are? Blue paths are paths of Totality. And the red paths are paths of annularity. Very good. And so we have to go back. We're going to go back way back to 1979, where the path of totality, blue lines, was in the remotely populated area of the Pacific Northwest. All right, so let's go ahead and go on to the next slide, please. Oh, I got a clicker. Okay. So, click.